Hello everyone, George here, and we are now up to Chapter 2 in the Game Programming in C++ book. Although this isn't the complete Chapter 2. We're actually only going to be looking at the first half of the chapter. The reason for that is because there's a lot going on in this chapter, and really it's kind of two different parts. The first being taking the entire Pong game, which we already have, or really the framework of anything, and breaking it down into a game object or actor-based system, similar to what you would see in Unreal or Unity in terms of having one class that contains components stored in some sort of a list or a vector, and then adding those components. The second half of the chapter is involved with sprites and loading in textures and putting them on the screen. So this first video is only going to cover the first half of that chapter because really it covers so much that I didn't want to do it all in one video. So what I've done here is I've taken that Pong game from before and I have split it up using this actor or game object type system. Before we dive into how we created this in a more object-oriented fashion, let's just take a look at the main function. Just like before, we have game, we check to see if it's initialized, and we're going to ignore this stuff for just a second. And instead, we're going to come down here to the end and notice that if we were successful in initialization, we're just going to go ahead and start running our game loop. And then once we exit out of that game loop, we're going to go ahead and shut down. Now, what is all this stuff above? Well, that's actually setting up the game now. Because we're using a system where we create actors, which are the game objects in our scene, these are objects that have transformations, that is a position in space using a vector 2, and they also contain any functionality or features to make that individual object work. So gone are the days where we just threw everything into the game.cpp file and did updates inside of there. Instead, each and every one of these separate classes is going to inherit from actor, and it will then implement its own functionality based upon what that object is. This makes it very easy for us to extend and create a whole entire new system without modifying the underlying architecture of our engine. How does that work exactly? Well, we'll have a base class, that is our actor class here, and that is the bare minimum functionality we need to make everything work. Inside of actor, we have different states to say whether or not that actor is active, paused, or dead. I'm not currently using the states yet. What we do have, though, is our constructor, which you'll notice we take in the pointer to the game object itself, because the game is going to potentially have game critical information that just about every actor might need, but also it's going to contain functionality and features that allow all these objects in the scene to maybe spawn other objects or destroy other objects. So it's important they get a pointer to this game in order to function properly. Of course, we have our deconstructor next. That's virtual, so we can override that later on. And then we have 3 different updates. Now, right now, this is the first half of everything. And in fact, the book doesn't even tell you how to do what I'm going to show you here. It kind of at the very end of it just says, there's really not enough here for us to re-implement the entirety of the Pong game. So I took that as a challenge to go ahead and re-implement all of the Pong using this object-oriented design instead. You're not going to find any of this in the book, so hopefully that adds something interesting for you to watch. So we have 3 different kinds of update. We have update itself, which is the actor object. So we've got 3 different updates going on here. And at the moment, the only one that really matters is update actor, which you'll notice is also virtual. The reason it's virtual is because we're going to be overriding that. In addition, we have an add component and remove component. At this time, I'm not using components, and that's because the chapter really doesn't start working with components until the second half when they start talking about sprites. Since we're not into that part yet, everything is going to be handled by the actor. So what you're going to see is a lot of actor subclasses instead of components being added. We will be changing this later on as we move on. The book is going to use something called a mesh renderer or a sprite renderer or whatever you want to call it to render out all the details. But for now, because this is just the first half of the chapter, I've instead added a draw function that can be overridden by any child class for actor. This is where all the SDL draw code is going to end up. And we also have a method here called getPosition. That's just to return the position of the object. And then we have some protected information. the state, the position, the scale, and the rotation. It's protected right now and not private because at the time that I did this, I didn't have this get position function, which was public. So I should really change that back to private at this point so that things don't mess with these. You can always create getters and setters to access the rotation, scale, and position information if you want to, and that's just a better way of encapsulating things. So the actor also stores a pointer to game, which gives us a lot of features and functionality we're going to need, and it also has this vector of components, which I am not using at the moment. That'll be something we get back to later. Why don't we go ahead and take a look at the CPP file. When we instantiate an actor here and the constructor fires off, we go ahead and set the position, scale, and rotation to something by default. In the actor deconstructor, very importantly, even though we're not using them yet, is the fact that we iterate through all of the different components that might be added. The book brings up an interesting example, but this isn't the first book to do it. I don't know how many game engine books I've read that talk about the Deadly Diamond and the Unreal Engine and the idea behind a vehicle class, and then an amphibious class, and then a land vehicle, and then of course trying to inherit both of those functionalities inside of a subchild class, and then running into issues where you're not sure which one gets constructed first, you're not sure which pointers get set up in the virtual table, and things get overridden. You can read more about that in this book or pretty much any game engine architecture book out there. It's pretty standard stuff if you look at any textbook. So then we have update, and this is the main function that gets called by the game engine. So it's first going to update the actor. So if the actor has specific code that needs to fire off that's pertinent to what it does, its behavior in general, it does that there. But then we also have the components. Like I said, at the moment, we're not using a component-based system, so it's not going to do anything yet. This function fires off down here, update components, that iterates through every component, and then it updates each one in turn. Here you can see that update actor at the moment has no code in it. It's completely empty because there's nothing the base actor class really needs to do. Then we have add component, where we just add components back to our list, my vector of components. We have remove component, which iterates through that entire list and erases anything that's inside of it that we need to. And of course we have the draw method, which is empty for any actor. We could put in a sprite or something else in there that just sort of says this is something that exists, but we're not going to. We might need invisible objects. You'll notice I have two folders over here on the side. We have an actor.header, and we also have our actors folder down here with our CPP files. Let me go ahead and put actor, the base class, in there. And then we have three other classes: ball, paddle, and wall. All of these were just code inside of game before. But now what we've done is we've taken all that functionality and tore it out of game. So if we take a look at game really fast, here's the header file for game. Not much different as in before, except that you'll notice a lot of the code has been removed because we're not setting things up for the paddles and the balls and so forth inside of game anymore, which is nice because it means the game class itself, the real engine of it, is pure. It doesn't have all this extra junk inside that might be confusing or that you'd forget, or ultimately just makes things less streamlined. We have initialization, run, shutdown, add actor, remove actor. That's new. You'll notice that those are pointers, so of course we need to make sure we destroy these things when we're done. We have a getter for the width and the height because other things might need to query that information. Just as before, we process input, update the game, generate output, and so forth. Our pointers for everything else is the game running. Our ticker that holds time, our window width and height, which gets set up during initialization, and then our storage for all the actor objects. There are three of these. The first one for actors are any active ones in the scene. Pending is because while we're updating the scene, or actually we're iterating through the actors, I should say, we do not want to add to that list that we're iterating over. This can cause problems based upon the type of loop that we're using to iterate over things. So if something new gets created, maybe we have a gun actor and it shoots a bullet. That bullet now might be an actor itself, some type of a child called bullet that would inherit from actor. We don't want to necessarily update that yet. So instead we put that in the pending actors list. And after we've updated everything in this current round, we're going to take everything out of pending and then shove it into actor so that the next time we have a game loop, it will get updated. But it's not going to screw with anything while we're still going through that loop, right? Because that one loop is one instance in time, and we want to update everyone in that instance together. We have a list for dead actors. These are ones we're going to have to garbage collect and handle when we're finished, and those are going to require special considerations. That's why we put them in a separate list to handle. And then there's a part of this that says, are you updating the actors? This is how you distinguish whether or not you're supposed to be adding actors to the actors vector or the pending actors vector. So going over to game.cpp, this is a lot cleaner now than what we saw before, where it was tons of code with paddles and balls and all sorts of nonsense, right? So instead, we have our initialization, same as before for the most part, except we're no longer initializing any elements of the paddles or the balls or the walls. It's all taken out of here. Shutdown, same as before. Here's where things get a little bit different. Here we add an actor. We check to see if we're updating those actors, and it figures out which one. We either add it to the pending actors list or the actors list. Removing an actor. The book completely glosses over any implementation of this, and they just give you like a single line that says, the remove actor will remove the actor based upon whatever it is. So to do that, we're given a pointer, right, which is a memory address that says where in memory this object is located. So all we do now is we iterate over every actor, and we see where it is. And if we find it, which is right here, we go ahead and delete it and get rid of that thing. We call both delete and erase because erase, if I remember correctly, erase, if you call it and the object isn't a pointer, it will destroy it. However, delete needs to be called if you're dealing with a pointer to make sure that deconstructor is called. So that's why you see those two different steps. Also, when you pass in this pointer, I expect there to be only one element inside of there. So I return instantly after I find that. This probably requires a little bit more type check, or not type checking, but a little bit more care, because nothing's stopping someone from adding multiple pointers of the same object to add actor currently. And that might be something I want to check out. Or what I really kind of want to do is make the constructor for actor like private, and then require you to go through game engine to instantiate anything. Possibly. I haven't thought that through tremendously, but I do know in some of the other programming books I've read that using, what is it called, a factory, I believe is what you'd call this, where another class is responsible for creating the instances, might be a good way of making sure I don't screw anything up here. We'll get to it at some point. Processing input. This is really in the game class just for handling exiting, or really just exiting the game at this point. Then there's the update game loop, and this is where we tore everything out and then started throwing it in those other classes. All we're doing here really is checking time, and then we're going to iterate over every actor, call update on each one, passing it however much time has progressed, and then going through any pending actors, and then taking all the ones that were in the pending thing and shoving them back into the actors list after we're done updating. Then we need to do our personal garbage collection, right? This isn't C# or Java. We need to go through here, find anything that's been killed, grab all those objects, and then remove them from our list, and then put them in the dead actors list at that point. And then delete all of those objects inside of that list when we're finished. Here we emplace dead actors to the back. We go ahead and delete actor, but I'm noticing that I'm not actually clearing it. It might be a good idea for me to do that. So if we do dead actors and then just do a .clear really fast, there we are. That's just to make sure that the whole thing is purged. All the dead stuff should be gone. So we might as well clear that list just to be 100% sure about that. Then we have generate output, which is stupid simple now, right? Because all that functionality has been moved out of the main game class and into those individual classes for actor. So all we have to do is iterate over each one and call draw. This is where I have deviated from the book for now. When we start getting into the sprites and the components shortly, hopefully in the next few days, this function will disappear and it will become a component, and the component will handle drawing things. And then we just swap our buffers. Take a look at one of these other classes. The easiest one is wall, because wall is a static object. We have our constructor, deconstructor, we update the actor, which is nothing for a wall. We also do setRect. SetRect is a function I created in order to set the rectangle. That is the drawing element used by SDL. And then finally we have the draw method, and then we have a thickness, which is how thick the wall is. Now if we take a look here at the CPP file, we can see we go ahead and set up our rect. Nothing happens in the deconstructor because it's a wall. Nothing really needs to happen. Update actor does nothing either. It's a wall. But then we have set rect, which just takes in the XY position for our rect, which is the upper left-hand corner, and then the width and then the height of that object, which you see here. And then finally, drawing a wall is stupid simple. All we need to do is set our render color. Here it's set to, what is this, RGB. And then we have set render fill rect, which we pass the rect into. And of course, we have to have a pointer to that renderer from SDL. So that gets passed into each of these whenever whenever draw gets called. Wall is easy. Let's go to something a little bit more complicated. So the way I programmed this was I did wall first, got the walls working. Then I went into paddle and got the paddles working. And then I went into ball and got ball working because ball has a lot more complicated collision detection than all the other elements. Ball actually needs to have references to other objects. Paddle just needs to know the extents of the walls because it stops them from going up and down, or the screen size, right? Ball, though, needs to not only know the walls, it also needs to know where the paddles are to do proper collision detection. Since it is the most complicated of the three, that's why I waited to the end to do that one. Looking under paddle, we'll go ahead and inherit from actor. We pass in a initial position X and a position Y. We do an update actor. Notice how they're both overridden for this particular one. One thing that I did do was I added a set key up and a set key down function. This is once again so I can generalize functionality. Instead of having a paddle for player 1 and a paddle for player 2 that have specific code, you simply create the paddles and then you specify what the key code should be by passing them in here. Then we have a get height and a get thickness because the balls actually need to know the thickness of the paddle in some of their calculations. Now, the reason why ball needs to know so much at this point is because ball is also handling its own collision detection. Of course, for a paddle, we also have a speed and we have its direction, and then we have those two scan codes that we mentioned before. Going into the CPP file really fast, we can take a look here. We initialize everything, set it up, so all that code is now inside of here for establishing the initial rect. We then go ahead and have our functions for passing in our key codes. We then have update actor. Update actor, once again, remember, does all the work for us. It is going to go ahead and grab the keyboard state. So we have our state, we check to see if it's up or down, and then we go ahead and update the paddle after we get that keyboard information in, adjusting its position. Update actor is simply for updating internal information about that object. It's not for drawing yet. That is why we have this separate draw function, which in the future will probably be a component attached to this instead of a function in actor. We pass in a pointer to the SDL renderer so we have something to draw to and issue commands. We go ahead and set our draw color. We go ahead and change the rect.x and y position because the paddle's height and width don't change, at least not yet. We don't have any power-ups that do that, but we always could if we wanted to. And then we go ahead and we issue an SDL render fill rect using that rect that we just modified. Let's take a look at the more complicated thing, and that is the ball itself. So here's the ball's header, very small once again. We have two constructors. We've got one that just takes in the game, but I did create the constructor so that you have to pass in paddle 1 and paddle 2. Yes, maybe we would have more players than that, and this should actually be a list of paddles that you passed in. But for right now, it's only 2-player. We're not going to get that crazy with it. So then we also have a second constructor, which is the one that I actually use, which is not only paddle 1 and paddle 2, however, it's also the position, the X and the Y position, and then the velocities of these balls. Deconstructor doesn't matter right now. We have our update actor and our draw actor, which of course we need to override. We have our velocity, we have our thickness, and we have our 2 pointers to the 2 paddle objects. Coming over to paddle.cpp, setting everything up in our constructor once again. Next up is draw. Once again, we get past the renderer, set our render color, go ahead and calculate our X and our Y positions for the ball. We don't need to change the thickness. Once again, the thickness is always going to be 15 unless we change things through a power-up at some point in the future where we could reference changing that thickness. But then all we need to do is a width or height, and then set that to be whatever the current thickness is, if we wanted to do that. I'm just not doing it because we don't have that feature or functionality yet. Then update actor. We have to go through and take our velocity and use that to update the position. That's easy. The harder part is checking the collision against all of the walls, right? Luckily, the walls are kind of stuck. Really, when the system gets more complicated, you're going to want some collision system that has access to all these objects and is telling you when these collisions are occurring. But for right now, I know that I only have a top wall and a bottom wall and that their thicknesses are whatever their thicknesses should be. I should be really querying the wall and asking for its thickness. This is lazy on my part. This is because I set the thicknesses of the walls to be the same as the ball. Yeah, George, bad idea. I'll probably fix that at some point. Next up are the paddles. This is the more complicated part, and this is where I had to have a reference to the paddle object to query where it currently is, as well as things like its thickness, in case we did change, because In Pong, right, one of the easiest power-ups is to make it longer, right, or smaller to mess with the player. Here we've got to go through, and it's the same code as before. The only difference now is you'll notice I have the paddle pointer, and I'm calling getPosition to query that information and using that in my mathematical calculations for each of these things here. Same thing down here. Thicknesses as before, the paddles, the positions, and so forth. And we do that twice. We do that for the top one, and we do that for this bottom one right here. Yes, in a perfect world, I would pass in a list of paddles. It would do the same calc for both of them, and we would be done. Not quite there yet. So you're kind of getting to see how we're half-assing things partway through. So now all we really need to do is take a look at the CPP and how all this works. So we initialized our game, like we said. We set up the wall object. So here's a pointer to a new wall. I do not need to worry about deleting these here. The reason for that is because the game engine, when the deconstructor is called, iterates through all of the pointers it has and deletes them. We go ahead and call game.addActor. This takes the pointer, throws it in the bin for our game, and it is going to iterate over all of those and update them accordingly and draw them at the appropriate time. Then we go ahead and create our paddles, same thing as before, 2 new paddles, passing it a reference to the game object, passing it our start positions as well. Remember, by giving each paddle an X and a Y start position that can vary, that's what lets us have a single paddle class, but have 2 different paddles on different sides of the screen. Here you can see I also go ahead and set the keys up for the scan codes for player 1, W and S, and for the other scan codes, I and K, and then we add both of those actors to it. Now this is the more complicated part. This is where we're dealing with the balls. It's really not complicated, but I left it to last because it seemed the most complicated when I was implementing it. We've got our loop. It's going to create our vector2 objects with our positions. I did tweak the code from what you saw in chapter 1, and that's because I actually made a bit of a mistake here and there. I wasn't doing the proper radian calculation. So what I have here now is, if I need it, a division for however many balls I have, how to split the screen up, and the distances in pixels between each one. But more importantly is, I was using 2 pi, right? So it's an entire circle going all the way around. And I'm using that to determine the velocities, the starting velocity, so that the balls shoot off in different directions. My equation wasn't perfect last time, and I made a mistake. So I've updated that here, where I take 2 pi, which is 3.141592, or whatever, if you're an engineer, it's 3, right? I multiply that by 2, so we have the full circle, and then I divide that by I plus 1. Of course, the reason is because I on the 0th iteration is 1, so adding 1 to it means I'll always have at least, I won't have a divide by 0 error. Then we have vector2 ball vector. We go ahead and use cosine. This is what I screwed up last time as well. I had sine and cosine flip-flopped. I had sine on the x and cosine on the y. I want the y value at 0 to be equal to 1, so I need cosine to be in the x slot, not the y slot instead. I multiply this by an arbitrary force or velocity vector, in this case just a scalar of 200 times whatever this is. So this will be 1 to start off with, this will be 0, so it's going to fly off in the x direction first for the first ball. Any additional balls that get added, we're now going around that unit circle for it, and each one is going to get a different quantity of x and y. And then we add any balls that we generate into the game itself, and then it gets updated on its own. So let's go ahead and see this run, Control F5, and here we go. Oh, so there are the balls. Oh, I missed, that's bad. I'm not very good at this game and trying to record at the same time and do everything else. But here you can see the balls are responding to the paddles. They're bouncing around individually, going wherever they need to. Oh, I missed that one. That's interesting. So my collision isn't great yet, and that's because we're not doing a great system for collision itself. You'll notice it bounces off. It's very simplistic, so I can't hit it from the corner. I'm not differentiating between where on the paddle it hit. So there you can see I was in the ball, but because I was in it, it still registered as a collision. Really, I should have pushed that ball off, and it went off, and went around me instead. Now, hopefully, and this is going to be a little bit, chapter 10 in the book talks about collision detection. So we will start putting some basic boxes around objects. I don't know if they're going to use axis aligned bounding boxes or what, or maybe we're going to split everything up into a tree and check collisions. I haven't gotten that far yet. That will create a much more robust collision system than what we have currently. It's kind of weak at the moment. I completely understand. And that's it for the first half of chapter 2. And since the book doesn't tell you how to do it, I really wanted to take a minute to show you how I decided to implement it myself. Something that's a little more original than just following along with a textbook. The next video, we're going to look at the second half of chapter 2, where we'll implementing sprites and animated sprites. And hopefully either we'll update the Pong game or we're going to strip the Pong game completely out and then make something new and interesting to show all those features and functionality. Difficulty level for this chapter? Squarely an intermediate. They do not give you a lot to work on in the textbook. If you use their GitHub repository, you can figure out everything that's going on. But once again, I don't like to copy and paste stuff. I like to figure it out. So it's up to you. I took the challenge of doing it all on my own, looking stuff up, checking out the containers, looking back into Vector again and making sure I understood how to add things or remove things or what erase does, if it calls the constructor or not, so forth and so on. So I would recommend doing it yourself, trying to see if it works, and then checking their code out on the GitHub and comparing how well you did on your own. Well, that's it. I will see you next time. So long, everyone, and goodbye.